All right. Okay, so the first slider we want to create that's going to help us kind of line things up and know where our asymptotes are is the slider x equals 0. So you just type x equals 0 and press enter, and now we have this line that you can't see because mine looks like it must be black. We're going to do y equals 0 as well in the next line, and then we're going to change the color of things. And that's why I typed an S instead of an X. Okay, so we should have two lines now that follow the x and the y axis. Everybody with me so far? Okay, so let's make those asymptotes a different color. So when we want to do that, we're going to click on this Edit List button. It's a little gear icon. And we can change that color to whatever color you want, provided it's one of 6. And then you're going to use the dashed little guy so that you can see those lines as dashed lines as opposed to solid lines. All right, so now we're ready to graph our first equation, and that was the good old reciprocal function, y equals 1 over x. So you can type y equals 1 over x, or you can just type 1 over x, and it will automatically supply the y equals. All right, everybody get what we expected? Our good old reciprocal function? So what I want you to do is I want you to sketch that quickly, and it doesn't mean that we're plotting any points, just the general appearance of this graph. Since the asymptotes are kind of already the axes, there's no need to add any asymptotes to it. So we just make a quick sketch of this. And then we're going to ask ourselves as a good review of our domain and range. So this guy looks something like this. And what were our two asymptotes? Yeah, x equals 0 is a line, and y equals 0. Those are the two lines that it approaches but doesn't touch. So when we're looking at the domain of our function, what would we say the domain is? Good. I love that you're using interval notation, negative infinity to 0, not including 0, so parentheses, and then from, yep, not including 0 to infinity. Okay, so we had a problem at 0, and that's why we have that asymptote there. We approach it, but we didn't touch it, and then we continue on from the other side. What about our range? Bottom up, yep, same thing. Bottom up, negative infinity to 0, and 0 to infinity. All right, we're ready for the next one. So this time, f of x is a negative 1 over x minus 2. Changed things up a little bit, didn't it? So is x equals 0 our vertical asymptote still? No, so let's use that slider and let's move it over. And what do we think our vertical asymptote is? 2. It looks kind of like 2, right? Is that to be expected based on what we know about the parent function? Yeah, we moved 2 to the right, didn't we? Okay, so our important points are 2 to the right, but then it also did something else, didn't it? It reflected it because of that negative, didn't it? Reflected it across the x-axis. So let's make a quick sketch. This time when we make our sketch, we want to include our new asymptote at 2. And if we want to show that that y-axis is still, or the x-axis is still the horizontal asymptote, we can by putting dashes there. And then this one is the opposite of what we were expecting. because of that negative. If you want to make a note, it's reflected and shifted right to. So from our sliders, we know that our asymptotes are x equals 2 and y equals 0. So what's our domain this time? Mm-hmm. Good. Absolutely. And what's our range? Same as the previous, right? Negative infinity to 0, right? And 0 to infinity. Okay. So we're ready to modify. We're going to put a 4 in the numerator and an x squared plus 1 in the denominator. And remove that negative sign. So you've got that little keyboard that you can bring up to give a squared term. Everybody get something that looks like mine? Okay. Oh, sorry, x squared plus 1. My fault, not 2. Thank you for catching it. That looks more like it. All right, everybody got something that looked like that? Okay. So, as far as asymptotes are concerned, what happened? Yeah, there's no vertical asymptote here, is there? So for the moment, let's hide it. Let's hide that x equals 2 by just clicking on it. So that line goes away and we're not bothered by it. Did the y asymptote stay the same? Yeah, so let's go ahead and write y equals 0 for the only asymptote that we have this time. And we're going to put that, understand that we have that dashed horizontal asymptote there. And then what happened? Really close, up as high as 4, and then it went like that, didn't it? Okay, so what's our domain? Absolutely. We have no restrictions on our domain this time. But what about our range? 0 to 4. So can we be 0? Nope. Can we be 4? So close the bracket. All right, last one. Mm-hmm. Mm-hmm. Okay. Gotcha. If you click on this guy, it's going to let you change your zoom. So your x-axis can be similar to mine. Let me see what we have. All right, so I have from negative 10 to 10 and roughly 6 to negative 6. So if you type negative 10 in there and then 10 there. And that's going to be more like it. And then, yep, then you're fine. Or you can just slide it up. Yep. You're welcome. Okay, so what happened with this next one? Okay. All right, so the next one is x over x squared minus 1. And it's just never going to stop, is it? It just keeps going and going and going, doesn't it? So it looks like it didn't turn, did it? So what's happening is it's coming from the left, and what happened? It went down to negative infinity, right? And then it started up here at positive infinity, and it went down through the origin down to negative infinity, and then it went way back up to positive infinity, right? and then came down and headed off to 0. So it never connects, okay? And that's what's weird is when you put those asymptotes in there, if they're not dashed, it makes you think that, and if you do it in your graphing calculator and you tell it connected, then it's going to draw those asymptotes, even though that they're really not part of the graph. So we need our asymptote back, don't we? In fact, we need more than one. We need the x equals 2 to come back, but what should its value be? Looks like maybe 1. So let's drag it over and see if it could be 1. Okay. So that looks like it's kind of lining up between them, right? Now, some of you have done a large amount of scrolling. So if you go to your graph settings and you change your x-axis to have a range of -10 to 10, and then your y-axis to be about -6 to 6, you'll be kind of back to where you were to begin with. Is there a home button? On the iPad has a home button. Everybody find it? Okay. There must be a Zoom standard type thing. Everybody find it? Just click on that, and that should take you back to your normal. All right, so we've got one of our vertical asymptotes. Looks like we need another one. What do you think the other one should be? -1. Let's try it. So we're going to add a new one, and we're going to call it x equals -1. And then we can change that again so that it has a dashed appearance, and move it up with the other x so we're together. All right, does that seem reasonable? How about our horizontal asymptote? Do we have to move that? No. Okay, so I heard people kind of freak out about this one, right? Because what happened? Yeah, we have 3 asymptotes this time. And what else? Yeah, it went through one of those asymptotes. What kind of asymptote did it go through? The x-axis, the y equals 0 asymptote, didn't it? So that's behaving differently than what we're expecting. Typically, we've always said you don't cross an asymptote, right? Well, our rule is always going to be that we don't cross a vertical asymptote, but on rare occasions, we may end up crossing a horizontal asymptote. Okay, so that's something that's kind of different and unique that you'll see in pre-calc that you didn't see in Algebra 2. Okay, so let's sketch it out. So we've got something that looks like this. We need a 1 for our asymptote, and a -1 for our asymptote, and a 0 for our asymptote. And we did something like, let's see. We did something like this. And then we did a little jog through the origin and across that asymptote, horizontal asymptote, and then something like that. All right, so far so good? Okay, so lots of asymptotes this time. They are yep. If you want to save yourself a little writing and say x equals plus or minus 1, that's okay. All right, domain. -1, 2, -1, 2, 1, and all excluding those values, right? So parentheses there. What about the range? -infinity to +infinity. Do you agree? Why not? No, we want to say it's going to be a problem of 0, don't we? But this guy broke the rules, and he gets to be everything from bottom up, -infinity to +infinity. Okay? Breaking our perceptions, making us think. So far, so good? Okay, let's summarize. All right, what caused these functions to have one or more vertical asymptotes? So we see some have x's on top, all of them have x's on the bottom. We have maybe some shifting going on. Because they have some kind of x in the denominator, seems like it's a good potential reason. Well, we want to be more specific because I want to be able to give you one of these and say draw it. Okay? Okay, so which one didn't have a vertical asymptote? The third one. Okay, so let's start there. What made this one not have a vertical asymptote where those three did? Okay, this one was one that had an x on top, and this one did not, but those two didn't either, so it's not about x on top, right? Something maybe with this x squared. This one's x squared minus 1, but this one's x squared plus 1. The subtraction versus the addition. What could make the subtraction have asymptotes and the addition not? I like where you're going. Imaginary numbers only happen when we have square roots, though, right? Square roots of negatives. We're not dealing with square roots here, but what are we dealing with? Squares, but what were the two rules we said we couldn't do in the real number system? Divide by 0. Could that be causing our problem? If we try to divide by 0, does that cause an asymptote? If we try to divide by 0, does that cause an asymptote? And that's what's going on, right? This is saying, hey, wait a minute, dummy, you can't ever divide by 0, right? And so we're going to go on and on and on forever and get way high or way low, but you never, ever, ever can hit that number that would make us divide by 0. Does that make sense? So what was that number here? Ooh. Okay. What's this number here? But what happened here? Yes, we'll always have a positive number from squaring, and we're adding a positive number to 1. It's never going to get to be 0, does it? Can't be 0. How about here? All right, so x squared minus 1 can't be 0, right? So x squared can't be, yeah, x can't be positive or negative 1. Uh-huh. Cool. It's a lot better than just being told something, right? Yeah, I think it's better to explore it and figure it out. Okay, so far so good. And there's emotion attached. When you find something out and you say, oh, there's emotion attached, so now you have more neural connections and you can retrieve it better. Okay, so far so good? Okay, so what caused them to have one or more vertical asymptotes? X squared minus an integer, or even more general, because not all of them were squared, but just a denominator that has the potential to become 0, right? Okay, any values of x that make the denominator 0. So far so good? Okay, now I'm going to ask you about the degrees of the numerator and the denominator. We want to look at those and compare them. First one, what's the degree of the numerator? X to the 0 power, right? There is no x up there. And x to the first in the denominator. So we have a degree of 0 and a degree of 1. Okay? Numerator, we have a degree of 0 and a degree of 1. Degree of 0 and 2. Degree of 1 and 2. Okay? So what's true about all of those? No? They have some. the denominator's degree is greater than the numerator's degree. In terms of the horizontal asymptotes, what happened with every one of them? They are all y equals 0. Feeling good? All right, next one. So now we're going to plug in x squared minus 1 over x squared minus 2. We probably don't need 3 asymptotes, so you can hide the ones that you don't need. All right, everybody get something that looks like mine. Oh, I have a 2, not a 1. Minus 2. You might have to put, you might have to put parentheses around things in order to make something happen with your division. All right, x squared minus 1 times over x squared minus 2. Got to move some asymptotes. So that's our next group. So if we move down on our sheet, okay? So if you want something to be, a couple things to be in the parentheses, or on top, you can put a parentheses around it and put your x squared minus 1 in the top parentheses and close the parentheses and then divide, and it'll put everything else in the bottom. X squared minus 2. You can group them. Okay? Should. All right. So where are we moving our asymptotes? I'll put it outside the parentheses. There you go. Divide by. And then x squared minus 2. So put that x squared minus 2 in the bottom, and then go back up and switch that 2 to a 1. Oh, you had it? Okay. Yeah. Okay. Oh. Oh, it's just that you have your different. So hit this home button. And there you go. All right. So here we go. What'd you get? No idea. Roughly 1.4. Did you see though that when you tried to scroll to it, it actually does cross when it's 1.4? Okay, so we don't have quite enough accuracy for this one, but 1.4 is pretty close for the moment. Okay, and then what do you think the other one's going to be then? Negative 1.4 roughly. Okay, so just hold on to that thought for just a second. Let's get our y going. Y is going to be what? 1. Okay, so we're going to move y up to 1. I can get my 1.4. Yeah, but it does, yeah. So the 1, if I zoom in and out, notice that it's never going to cross that 1. Okay, it gets really close, and then actually the closer I zoom in, the further away it looks. Okay, so we're okay with that. I'm going to hit my home button. Okay, so let's deal with this 1.4 stuff. Okay, earlier we said, well, let's just sketch it to begin with. So we have something a little bit bigger than 1, something a little bit smaller than negative 1, right? And we have an asymptote at 1. So let's sketch that out. All right, so let's think about those asymptotes. Before we said that we would have vertical asymptotes whenever we tried to divide by 0 in the denominator, right? So what's going to make this equal to 0? X squared will be equal to 2. When we take the square root, it's going to be plus or minus the square root of 2, which happens to be 1.412 blah, 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 blah. Okay, so 1.4 wasn't quite accurate enough, but if we could have put the square root of 2 as one of our steps, we would have been fine. Does that make sense to everybody? All right, so asymptotes then. The x asymptotes are plus or minus the square root of 2, right? And what was our y? 1. All right, so let's look at domain. What's the domain of this guy? Good. Absolutely. And this is where the interval notation kind of breaks down. It would have just been easier to say all real numbers such that x is not equal to positive or negative square root of 2. Ends up being more writing this way. All right. So negative infinity to negative square root of 2, negative square root of 2 to positive square root of 2, and positive square root of 2 to infinity. How about the range? This one's tricky. Start at the bottom. Smallest it can be is negative infinity. What's the maximum value it gets to be? Let's verify. Let's actually click here because it will, since it's a special point, it's going to give us a point. 0.5. So this one happened to get as big as 0.5, and then we have a gap, don't we? Okay, so we're negative infinity to 0.5. And what do we use for our closing thing here? A bracket. Okay, and then what happens? 1 to infinity. And what do we need for our grouping symbol here? Parentheses. Doesn't get to be 1. Okay? Make sense? Next one. Onward, forward. Now we're going to do x minus 2 over 2x minus 5. It's like we have way too many asymptotes, right? So let's hide one. Let's move them. What do you think for the x one? 2.5. How about the y? 0.5. And we could zoom in if we need to and then reset it to go back, right? Does that look reasonable? Okay. Does that make sense? Y equals 2x minus 5. We set that equal to 0. Then 2x would be positive 5, and x would be 5 halves. 2.5, right? Okay. So we're good there. Vertical asymptote, we just make our denominator 0. Sketch it. All right, so asymptotes x equals 2.5, y equals 0.5. What's our domain? Yep. What about the range? So most of them are easy. There's just a few of them that want to trip us up and have something strange going on. All right, next one. 2x cubed minus 1 over x cubed plus 8. Your x cubed button is this a to the b button. Looks a little strange. Move those asymptotes. What does the horizontal asymptote look like it's going to be? -2. Does that make sense? Would -2 make a 0 in the denominator? -2 cubed is -8 plus 8 is 0. Okay. What about that horizontal asymptote? Looks like it's 2, doesn't it? Okay, so let's sketch it. Left side's a lot easier to draw than the right side, isn't it? All right, so we said our asymptotes were 2.5 or 5 halves, right? And y equals 1/2 or 0.5. Oops, I'm on the wrong one. No, I am on the. Oh, I'm sorry. Those were yes. I'm x -2 and 2. My fault. Heavens, I drew them right. Think and don't just look at the answer key, right? Domain. Yep. So this one wasn't crazy, right? So it gets easy when they're not crazy. You can just look at your asymptotes. The range. Just don't let them lull you into a false sense of security. Now we're on to our last one in this group. So in the numerator, we want 3x squared minus 2x minus 1. The range is going to be from negative infinity to 2 and 2 to positive infinity. We'll talk about just a second. Give me a second here. If I try and talk and type at the same time, I won't get it right. And that's strange, isn't it? So if you zoom all the way down, these are two different lines. Do they ever connect? Probably not. Because can they connect? No. What happens if we have an x squared and it becomes a 0? There's a addition issue with the denominator, right? Okay. So we know our vertical asymptote should be x equals 0. And our horizontal asymptote is strange again, isn't it? Every once in a while we get that strange thing that's happening. So what do we think this one might be? There is. Yeah, what happens with the horizontals, the verticals can never be crossed. But the horizontals, we ask ourselves, what are they approaching as we go to negative infinity and positive infinity? So what number is this approaching as it goes to negative infinity? 3. Now how about this one? 3. Since they're both converging on the same number, it can be a horizontal asymptote even if it's crossed. Okay? So, for tomorrow, you don't have to do bold face on down. Okay? But try to continue this on, do the slant asymptotes. You'll have to do some synthetic division. Okay? So bold face on we'll do together tomorrow. So finish the bottom of this page and the top of this one. Okay?